We know how to find out the value of a function at any given point just by replacing the value of the variable. But what is limit in calculus? But limit is not the value of a function fx exactly at x equals to 8, but the neighborhood point of x equals to 8. So what does it mean? Let's look into this example here now. There is a function defined in blue color, this line, blue color, that is y equals to fx equals to x square minus 1 by x minus 1. What is the value of this function at x equals to 1? We can see it is at x equals to 1. The function, if I replace the value of x with 1, then it is undefined, 0 by 0. But what is the value of this function at x not equals to 1? Then the value of the function, you just cancel x, factorize x square minus 1, and the value of the function that comes to x plus 1. That means if x equals to x plus 1, when x greater than 1 or less than 1, not x equals to 1. So if you look into this straight line here itself, this is y equals to mx plus c form, and where in the slope is 1. Slope 1 means tan theta equals to 1. That means the inclination theta is 45 degree, which is in the anti-clockwise direction. And what is the value of c? That is the y-intercept, that is 1. If you look into this graph, this is the point x equals to 1. But at x equals to 1, y equals to 2, this function is undefined. There is a break point at this break point. It is 1, 2. So up to which point at the left or right side of this point the function exists? So let's assume the right side of x equals to 1, the point is x equals to 1 plus h, and the left side is x equals to 1 minus h. Now what is the value of this function at x equals to 1 minus h? That is the left side. That is, if I replace this in this particular function, then it comes 2 minus h. Then what is the value of the function at x equals to 1 plus h? The function value is 2 plus h. Just I am replacing the value in 1 minus h and 1 plus h, both the cases at x equals to 1, y equals to x plus 1. Where h tends to 0, that means h is infinitesimal. So h is, let's assume it is 0.0000000001. That is equivalent to 0, but not exactly 0. When this 1 minus h, this point, is approaching towards 1, x equals to 1, that means the value of 2 minus h, that is increasing. That means the value of the function that is approaching towards 2. When the right side point is approaching towards 1, that means h is diminishing. That means 2 plus h, the function value, that is actually also diminishing. So it is, the function value is approaching towards 2. So both the cases for left point and the right side point, the function value is approaching towards 2 when h tends to 0. So when the left side point is approaching towards x equals to 1, I am writing this like this, x tends to 1 minus, the point is approaching 2 minus h, which is approaching towards 2. This is called left hand limit. For the right side limit, right hand side point, it is called right hand limit. When I am approaching, it is approaching also towards 2 because it is 2 plus h and h tends to 0. That means the left hand limit and right hand limit for this x equals to 1, this is equal, that is equals to 2. That means the limit exists at x equals to 1, but I cannot say x equals to 1, it is extends to 1, limit x plus 1 equals to 2. So for the left limit, when x tends to 1 minus, that is 1 minus h, when h tends to 0, we can write it down like this, x tends to 1 minus. And the value is 2 minus h, which is approaching towards 2 when h is diminishing. And for the right hand limit, for the right side point, x tends to 1 plus, and the value of the function, it is equals to 2 plus h. It is trending towards 2 when h is trending towards 0. So the left hand limit and right hand limit for at x equals to 1, the value is 2. That means the limit of this function at x tends to x equals to 1, it exists. So we can write it down like this, limit x tends to 1, x plus 1 equals to 2. So even though this function is discontinuous at 1, 2, but the limit exists at that point. So for any continuous function, limit exists at any given point on that function. But for the discontinuous function, the limit may or may not exist at the break point or the point of discontinuity.